Let's take a look at this problem. We got our cost function equal to 0.5 x squared plus 30x plus 1000. And the instructions say find a number of units x that produces a minimum average cost per unit. Now our average cost per unit is C bar is equal to C over x. So that's our formula. So first let's find that. So C bar is equal to C over x. So we got 0.5 x squared plus 30x plus 1000 all over x. Now before we take derivative of this, we can split them up in a separate fraction since we have a single term down in the denominator. So we got 0.5 x squared over x plus 30x over x plus 1000 over x, which gives us 0.5x plus 30, and the x here I can take up on top and it becomes 1000 x to the negative 1. Remember that's the same as x to the first power, so we take it up on top and then it changes the sign of the exponent. Well, now we're ready to take our derivative. So take derivative of our minimum average cost with respect to x. Derivative of 0.5x is 0.5. 30 drops away. This one, the 1000 stays out in front. Take your power, put it out in front, lower it by 1. So that gives us 0.5 minus 1000 x to negative 2. Now we want to rewrite this a little bit. Seems like it's raining out. We'll take that x to negative 2 back down to the denominator, so it becomes x to positive 2. Now this 0.5 we can put it over 1. If we're going to add or subtract fractions, it's handy if they're both fractions. We want to get a common denominator, which would be x squared, so multiply the top part by x squared and the bottom part by x squared. So we got 0.5 x squared over x squared minus 1000 over x squared, which merges into a single fraction, and we got 0.5 x squared minus 1000 all over x squared. Now we got a single fraction, so to find the critical values, we'll set the top part equal to 0. So we got 0.5 x squared minus 1000 equal to 0, and we got x squared equal to 0. Well, the x squared equal to 0, if we drop the squared, we just get x equals 0, and that doesn't make any sense for x equals 0, so ignore that one. If you get x equals a negative number or x equals 0, you can cross those off. So this one, we'll solve this. 0.5 x squared, I'll take the negative 1000 to the right side. Divide both sides by 0.5. 0.5 x squared divided by 0.5 equals 1000 divided by 0.5. Those cancel, gives us x squared, and I think that's 2000, but let me plug in the calculator just to make sure. Not very good with decimals. 1000 divided by 0.5, 2000. Now I'm going to use a square root property. I'll drop my squared and put a plus or minus square root around the other side. Now remember what I said, negative units are not going to make any sense, so we can ignore the negative part of this. We'll go with positive, and let's see what square root of 2000 gives us. So do second x squared, 2000. Purposes of these problems, I just want you to round like normal. So 44.7 gives us 45. Now I want to build a table of intervals. Over here is negative infinity, or if you want to think of it as 0, you can do that. Over here is positive infinity. I'm going to choose test cases, something between 0 and 45, like 1. Something greater than 45, like 50. Now we want to plug them into our derivative. And here's our derivative. There's no use to plug it into the bottom part because the x squared, when you square something, it's always positive. So the top part is the only part we have to plug it in. We got 0.5 times 1 squared minus 1,000. 1 squared is 1 times 0.5 is 0.5. 0.5 minus 1,000, don't know what it is, but it's negative, so it's decreasing. If I put 50 in there, 0.5 times 50 squared minus 1,000. 50 squared is 2,500 times 0.5 is 1,250. 1,250 minus 1,000 is positive, so it's increasing. So it is indeed a minimum here. And I think they were asking find the number of units that produces the minimum average cost. They don't want to know what the average cost is. They just want to know how many units. So x equals 45 will be our answer.